Okay, good morning. This is Miss Webb. This module, we're also going to use tables and technology to estimate the area under a normal curve. So in the last lesson, I did one example on how to use the table. I would highly recommend using the table for all of these. It also suggests being able to use a spreadsheet if you happen to have Microsoft Excel. A lot of times in your physics classes, you're going to use a spreadsheet to be able to determine some of these. You want to be able to interpret probabilities in context. And this one, select an appropriate normal distribution to serve as a model for a given data distribution. I think they have one example on that. So let's walk through this. Okay, so if you want to calculation of normal probabilities using z-scores, okay, and tables of standard normal areas. Okay, and we did this on the last example in the last lesson, but let's look at this one. It says the U.S. Department of Agriculture states the average cost of food is $261.50. Oop, let me get a pen here. $261.50. There's my mean. So I got a mean of $261.50. Assume the monthly food cost expressly is normal. You have to know that it's normally distributed. And here's my mean, and it has a standard deviation of 1625. 1625. Okay. Now it says use a table of standard normal curve areas to find the probability that the monthly food cost for a randomly selected 14 to 18-year-old male is less than 280. So here's my mean at 261.50. Here I wanted everything to the left of 280, and we talked about that table will give you the probability of anything to the left. And to do the table, you have to know your z-score. So I would have to know that, let's see, I'm going to pick 280. I'm going to pick 280 minus 261.50, divide it by my standard deviation, and I would get my z-score of 1.14. Now when I go to that table, let's go see what I'm going to do when I go to that table. Because I'm supposed to get, according to that table, 0.8729. I'm going to hop over to that table. Let's see if I still have it up. No, I do not. Let's bring it up. Or maybe it's over here. There it is. Okay. Now mine is a 1.14, so I want to be positive. So let me scoot down here to the positive. Okay, I'm going to do 1.1. There's 1.1 right there. And I'm going to go to 1.14. So I go all the way over here, and there it is right there, 0.8729. That's how I got that 0.8729 with the table. And remember, the table is the area of everything to the left. Okay, let's try another one. Okay, what if I want it to be greater than 270? In that case, I'm just going to say it's 1 minus whatever the area right here is from 270. Remember, the table tells me everything to the left. So if I go figure out my z-score right here, remember I figured that out by saying, okay, that's going to be 270 minus 261.50 divided by my standard deviation, which they gave me as 16.25, and that's how I got that 0.52. Now I'm going to look at the table, and when I look at the table, you should find this probability right here. And that is the area of everything to the left, okay, which is pretty high, about 70%, but that makes sense. It's about 70% of that mound. I do 1 minus that, and here is my answer. It's about 30% of it's over here. Okay, when I want p greater than 250, okay, again, when I figure out my z-score and I go look it up in that table, it's actually, the table's going to give me this area here. So that's why you're going to say 1 minus whatever that area over there is, and that's why I find this z-score, and that z-score again is 250 minus 261.50 over 16.25, and that's where you get that 0.71. You go to that table and you'll get 0.2389. So you say 1 minus 0.2389. Okay, now when you want to do one that's in between, what we're going to do is, here, let me do a highlighter. Okay, we're going to find the area of everything over here, because if I enter in this z-score down here in that table, it'll give me everything over here. Then I'm going to subtract off everything right here. And that's where I enter this z-score. Okay, so to find again my z-scores, okay, I'm going to take the 240 minus 261.50. I'm going to divide it by 16.25. That's where I get that negative 1.3. Was it 2? This one, 275, sorry, minus 261.50 divided by 16.25, and you should get about 0.83. I'm going to use these values in my table, and look, I'm going to get this, I'm going to subtract the second one, and that's how I get my probability. Okay, now if you want to explain the meaning of the probability that you found right there, if a very large number were to be selected at random, then you would expect about 70% of them to have monthly food costs between $2.40 and $2.75, because there's my probability. Okay, let's try another one. Okay, here's another one. It tells you the average cost of food. Let's see. Zooms. This one is a little bit similar. It gives you a mean of 215.20 and a deviation of 14.85. So you're really doing the same thing, but when you do the z-score, okay, here's 225. I'm going to be doing 225, okay, minus my mean this time is 215.20, and my standard deviation is 14.85. Okay, that's how I get my z-score, and then I go use the table. This example is exactly like the first one. And I've calculated the z-scores, I went and looked at the table, and I get my probability. When I want to do something like this, I'm going to do 1 minus whatever the table gives me for a z-score of 2.34. Because when I go look it up in the table, it gives me this area over here. Okay, this one, same thing. I'm going to get the z-score here, I'm going to look it up in the table, and I'm going to get that probability there. Subtract the small probability over here, and that's my final answer. So I went kind of fast over that one because it's identical. Some people weren't able to get to the example, that last example on the previous lesson. Okay, and I'm going to kind of skip through that one pretty. So I skipped through that one pretty fast because the first two examples are very similar. The next thing they want to talk to you about is being able to use the graphing calculator to find normal probabilities directly. So we can use that online function that I have. And also, if you don't have the z-scores, you can use, I want to tell you, if you're the TI-84, there is this function called normal, CDF. Okay. And on this one, you enter the left bound, the right bound, the mean, standard deviation, and it will give it to you. It's basically the same thing you're doing in the online calculator that I gave you. Okay, remember, if you're doing it on your calculator before, the other function that we used, you had to know your z-scores. But if you use this function, you can also do it where you don't know your z-scores. You can just know left bound, right bound, medium, and standard deviation. So I'm going to do this one right here, 260 and 265. I'm going to show you that online function. If you were going to put it in your calculator, you would put 260, 265. The mean was 261. Standard deviation was 16.25. If I go to that online function, let me go find that really quick. Here it is. Your mean was 261.5. Standard deviation 16.25. left bound, right bound. So you don't have to enter in z-scores. It's a different function on your calculator. Okay? And it will come out with 0.12204. Okay, let me go back. Okay, all of these, you don't have to worry about if you're all the way to the left, like you do on the tables. These, you just automatically put them in there. On this one, again, this one is a little bit differently in the sense that you're going to do the same thing, but your left bound is going to be 252. And your right bound, it's infinity, and they don't have a term for infinity, so you can just put like 999 in there. A really big number, and it will turn out okay. It'll give you a good probability there. And you would enter in, my mean of 261.5 and my standard deviation of 16.25. Okay, that's how you would do it with your calculator. We don't have, I don't know if you have your calculator or not. If not, you can go use the online function, and that is exactly what you would get. Okay, if you're talking about at most 248, that means here's my mean of 261, 248's over here. It's at most, so it's less than 248. It's going to be this guy over here. You can use your table for that one as well. If you use your table, though, you got to know what your z-score is. Or you can use the online function and you will get the correct probability. Try them, make sure that you're getting the answers correctly. If you're still having a problem reading the table, or if you're having a problem with the online function, let me know. If you have your calculator, awesome. I'd like you to try this one. If you don't, you need to make a note of this somewhere so that when we come back, you're familiar with your calculators and you can do it for your SAT. Okay, so in this one, let me see what they want us to do in this one. This is return to the information given in exercise 1. And this one, they kind of want to talk about what does it mean. So you're kind of trying to interpret what you got in exercise 1. So in exercise 1, you calculate the probability that the monthly food cost for randomly selected 14 to 18-year-old females between 190 to 220. And it said, would the probability that a monthly food cost for a randomly selected female is between 195 and 230 be greater than or smaller than the one between 190 and 220? Well, I'm going to draw like a picture here, okay? I have a normal distribution. Right about in the middle should be the 261.5, right? Isn't that the, oh no, this one's the mean where it's 215. Let me erase that one. This is the one where the mean is right at 215.20. And it says, okay, so if you had it between 195 and 230, well, 195 would be over here, 230 would be over here. So I've got this area here. Or between 190, that would be further out, 220 would be 10N. So they're pretty similar, but this one, it's 5 to the left. See, 195, 190, and then this one's 10. Okay, so on this one, I would say, if you look at a sketch, I would say there's more area under the curve for the wider interval of 195 to 230. See how this is wider? What's the difference between 230 and 195? You got 35 here. And the difference between these guys is only 30. So it's wider here. So I would say you have more area under the curve here. That's a higher probability. Okay, now this one. Do you think that the probability that the monthly food cost for randomly selected females between 195 and 230 is closer to 50%, 75%, or 190? Well, again, I usually kind of look at a picture here, and I'm looking at 215.20. That 195 is let's see, 230's got to be about, about over here somewhere is 230, and the 195's way over here. I would say it's about 75%. Okay. Again, you're just kind of doing an estimate, but you have to look and see if you have the mean and you know where the 195 is and you know where the 230 is, okay, exactly how much area is under the curve, okay? I think 90 is too high. I think 50% is too low. So I would go with about 75. Okay, now if you used your graphing calculator without using the z-scores, that's the same thing as using my online function, okay, then I would go put it in there, and I would have to know that it's between 195 and 230, okay. It says I'd have to know what my, I have to know my mean. My mean was 215.20. And I believe they gave you the standard deviation on example 1. Let me go back and look really quick. This is the one with the 215 mean. Your 215 mean is, go all the way back, is 1485. So it would be 1485. You have to know that. Okay, now you can either use my online function, or you could, again, if you had your graphing calculator, you could put it in there. Okay, and you have your left bound, right bound, mean, standard deviation. Okay, and also when you do this one, let me see what I actually got. I got, it's very close to 0.754, so it was close to this estimate of 75%. Okay, how does the probability you calculated in part C compare to the probability that would have been obtained using the table of normal curve areas? So if you use the table, and remember the table has to be everything to the left, subtract this little piece over here. So you would end up with doing a probability of let me show you what my z-scores were, because if I want to use the table, I have to do z-scores. So I have 195 minus 215.20 is my mean, divided by the standard deviation, and I get a z-score of negative 1.36. Okay, my other z-score, I'm going to say is 230 minus 215.20, divided by 14.85, and I get a z-score of 1. So when I want to go look at the table, I'm going to look at what's the probability when I have a z-score of 1, which I get to be 0.8413, subtract the z-score of negative 1.36, which is 0.0853, and I end up with 0.756. Okay, so it's still very, very close. We got 75%, 0.754, and 0.75. I hope that little skip there still went okay. Okay, what's one advantage to using a graphing calculator to calculate the probability? So you can think of the graphing calculator like my online function, and if that's the case, you don't have to know your z-scores. You can just enter in right bound, left bound like it is on the online function. Okay, let's look at some of the other questions. In exercise 1, you calculate the probability the monthly food cost is at most 200. Would the probability the monthly food cost for randomly selected is at most 210 be greater than or less than the probability for at most 200? Well, if I look at my little picture here, you have to know the mean is at 216. And here is 200, and here is at 210. So you definitely have more area with the 210 than you do with the 200. It would be greater. I always draw the little picture of a normal data distribution if you're not sure about things, okay? Okay, so the next thing it wants us to do is, do you think the probability of the monthly food cost, let's see, for randomly is at most 210 is closer to 10%, 30%, or 50%? Well, here's 216, here's 210, here's 200. I would say 10% is way too small. And 50%, no, can't be 50%. It would be way over there. So I'm going to go with, I'm going to say the area to the left, I would go with 30%. Because I think 10% is too small. 50% would have to be right here at the 216. So I'm going to go with 30%. Then they're going to ask you to use your graphing calculator, and that's my online function, and ask, what do you get? If you get it, you use the online, you're going to get 0.363. Very nice. Very close. Okay, and if you use a graphing calculator without using z-score, find the probability round to the nearest thousandth. The monthly food cost for randomly selected is at least 235. And again, at least 235 means the right bound is 235. Right bound is 235. Left bound has to be 999 if you're in the graph. If you're in the online, you'd have to put infinity in there. Your mean, and then your standard deviation, and this one you're going to get 0.091. Okay? Okay, let's look at example 3. Okay, in example 3, they want you to use a spreadsheet to find the normal probabilities, and I am not sure that you guys have access to Microsoft Excel. So I'm going to walk through this for you, and I'm going to tell you about what the function is in the spreadsheet. Okay, they're going to go back to this one where you have 261.50 and the mean, so the mean's 261.50, standard deviation 16.25, and they want you to find the probability, I think I got that cut off, is, oh, it's on the next page. Okay, they're going to want you to find probabilities, and they want this time for you to use a spreadsheet. So the only thing I'm going to tell you about this, because I don't know who has it, okay, is many spreadsheet programs have a built-in function to calculate normal probabilities. Okay, in Excel, this can be done by finding the area to the left of any particular cutoff value by typing the following into a cell of the spreadsheet and then hitting return. So this is very similar to my online function. This is your cutoff. Okay, let me put that in there. Your cutoff, your mean, your standard deviation, and then it says true. And let me see if it explains about the cutoff. The true needs to be included at the end in order to get the area to the left, okay, left of the cutoff. For example, if you entered in 50, it will find everything to the left of 50 where the mean is 40, standard deviation is 10, and then you put true. And it will give you 0.84124, and that's the area of the left of 50. So it's kind of similar to the table. It's only going to give you the area to the left, okay? But you don't have to have the z-score. You don't have to go in there and figure out the z-score, so it's still a little bit nicer than just the plain graphing calculator. So on these, like I said, these are you're going to have to be able to enter it into Excel, and I don't know if you have Excel. If you get any of these questions on, I have to go back and look through the problem set. Use whatever you want to use. You can use, I don't know if you have a spreadsheet. You can always use the table, and you can use my online function. Okay? Now, if you're using Excel for this particular question, it wants to know less than 280, and here's the mean. So you would enter in 280, 261.5 is your mean, and here's your standard deviation and true, and then we give you this whole area over here. That's in Microsoft Excel. If you wanted it to be more than 270, you have to do the 1 minus the probability, because it's only going to give you to the left of 270. So that's where you have to do the 1 minus. This one, it's more than 250. And I don't like the picture on this one. I almost want to say that this picture, I think these pictures are messed up. I believe, let's go fix that. This picture goes up there with this one. No, can't be. Maybe I'm just looking at 250. Let's see, is greater than 250. I think this is the wrong picture here. For this one, for the probability for it to be greater than 250, that should say the probability is less than 250 because it's everything less. If you wanted it to be greater, oh, I see what they're doing. I don't like the way they're doing this. On this one up here, it's more than 270, and they say it's 1 minus. You go and you find the area over here. On this one, they didn't stay very consistent. If you want it to be more than 250, you go into the table and you figure out the area of everybody over here, okay, which is what you did up here, but they did the shading differently, and you do the 1 minus. I think that's kind of confusing. I don't think they should have done it that way. Okay, on this one, again, you're looking at everything to the left of 275. You get that probability. Everything to the left of 240. You subtract them to get the area in between. Okay? Okay, let's see what they're doing on this one. Okay, this one it also wants you to try the spreadsheet. Okay? So, like I said, you know about the spreadsheet. You can also use the online function. And again, the online function, your left bound is negative infinity, right bound is 200, and your mean is 215. Okay, so when you do a spreadsheet, you don't have to do that. You would do less than 200. Your spreadsheet only tells you to the left, so you would only have to enter in that 200. You don't have to worry about the infinity. Okay? Let's see what another one is they have for us. Here's another one, and remember, it tells you to the left, so you're going to do a 1 minus. So try these with a spreadsheet, with the online function, with your calculator. Here's another one. When it's in between, you're going to take everything, the area, probability of everything over here to the left of this one, subtract everything to the left of this one, and get your final probability. Okay. In exercise 4, it's a really simple, it wants you to hopefully kind of look at a histogram, and if you can interpret some things about it in a histogram. And I'm going to give you the histogram. I don't know that we haven't really gone over histograms, but if you have the reaction of 490 people were measured and the results are shown in the frequency distribution below. Remember, a histogram is not the actual observation, but the percentage of the observations in that particular section there. So here's your frequency. Here's 9 down here. Here's 82. Here's 220. Here's 138. Here's 37. And it's about, what, 0.10 in between. Well, no, these are 0.5 in between them. And I hope that based on these numbers, you can see this. Okay, so this would be the 220, 138, 37, and 4. And then in between here, between the 0.30 and the 0.35, you're looking at 0.05. Okay, and do you see this up here? It's 0.10, 0.10 to 0.15. So you have about a tenth of a second here. Okay, and that's how you would do a histogram. It's not the actual observation, it's the percentage of observations in each of those. So when you're looking, okay, so if you're looking at the histogram, it wants to know, would you consider this a normal distribution? And I would say yes. This side's a little bit bigger, this one's smaller, but over here This one's a lot smaller, but it's approximately a mound shape distribution. So I would say yes. So I can use some of my my tools here. So my tools for this one is going to be, if I wanted to use it with a graphing calculator, and this is where you have to be careful. You have to know if you're using left bound only, right bound, if you're getting to use both of them. On this one, if I use my calculator, okay, that would be the same as if I'm using my online function. Okay, I am going to enter here my left bound and then my right bound. And my left bound for this example is 0.25. My right bound is infinity, positive infinity. And when you're using the calculator, you can enter in the 0.999. Then I have to enter in my mean, 0.2377, and I have to enter in my standard deviation. Okay, now if you were doing it in Excel, remember Excel or the table you have to know your z-score, and it's everything to the left of the z-score. If you're using Excel, it's the left bound, and it's going to be everything to the left. Okay, you don't get to do the two different cutoffs. Okay, so on this one, I do get a 0.394. Okay. Now, it says the actual proportion of these 490 people who had a reaction time that was at least 0.25 is 0.365. Okay, and how does this proportion compare to the probability that you calculated in part C? So they did this from a frequency. Does this confirm that the normal distribution is appropriate model? I would say yeah. That's pretty cool. So actually when they did it, you got the answer that it was 0.25, it's 36.5%. And when I calculated assuming a normal distribution, I got 39.4%. I think that's pretty good. I think I was pretty close. I would definitely think it's appropriate. Okay, let's see what else we got. Okay, so probabilities associated with normal distribution can be found using z-scores and tables of standard normal curve areas, and you have those tables. They can also be used directly without using z-scores using the graphing calculator, or you can use my online function. If you're going to use a spreadsheet, you don't have to have the z-score, but it's only the things to the left. It doesn't give you a right bound, left bound. Okay, now when you have a data distribution that has a shape that's approximately normal, then you can use a normal distribution as the model, and you can estimate the different things for the area and to see if it's correct. You can use the same mean, the standard deviation, as the data distribution is used. So it's pretty cool. Okay, that's all we got for today. I hope I didn't go too fast in this one. And if you have any questions, come see me or send me an email. Thanks.